Welcome to the Islamic University of Science and Technology, Avantipura. This is Department of Electronics and Communication Engineering. In the following lectures, we will go through the course Computer Architecture and Organization, whose course code is EC501, and it is designed for the 5th semester. Name of the course instructor is Mr. Sajad Ahmed. Starting with first chapter, that is Register Transfer and Micro Operations. In the introductory class, we will go through digital computer, program, computer hardware and software, block diagram of digital computer, computer organization, design and architecture. Starting with digital computer. A digital computer is a digital system that performs various computational tasks. The word digital implies that information in the computer is represented by discrete values, that is in the form of zeros and ones. These two values are said to be binary. A computer system is subdivided into two functional entities, that is hardware and software. Computer hardware consists of all the electronic components and electromechanical devices that comprise the physical entity of the device. The hardware is subdivided into three major parts as shown in the figure. It consists of random access memory RAM, central processing unit CPU, input-output processor IOP. CPU consists of arithmetic and logic unit for manipulating the data and number of registers for storing data. It also contains control circuit for fetching and executing instructions. Random access memory. The memory of the computer contains storage for instructions and data. It is called RAM. CPU can access any location in memory at random and retrieve the binary information with fixed interval of time. Input-output processor. It contains electronic circuit for communication and controlling the transfer of information between computer and outside world. Here, outside world can be keyboard, printer, magnetic disk drives. As you can see in the diagram, there is input device, and input device can be a keyboard, and output device it can be printer. Now computer software. Computer software consists of instructions and data that computer manipulates to perform various data processing tasks. A sequence of instructions for the computer is called a program. The data that are manipulated by the program constitute the database. As you know that the name of the course is Computer Architecture and Organization. Now we will try to understand what do we mean by the computer organization. Computer organization is concerned with the way the hardware components operate and the way they are connected together to form the computer system. Computer design. It is concerned with the hardware design of computer, or we can say it is concerned with the determination of what hardware should be used and how the parts should be connected. Computer architecture. Computer architecture is concerned with the structure and behavior of computer as seen by the user. It includes the information, formats, instruction set and the technique for addressing the memory. Now our syllabus starts with micro operations, register transfer language and register transfer. Now in the following slides we will try to understand these three important points. Micro operations. A micro operation is a basic operation performed on information stored in one or more registers, or we can say operation executed on data stored in registers are called micro operations. The result of the operation may replace the previous binary information of a register or may transfer it to the another register. Examples of micro operations are such as we have shift micro operation, load micro operation, clear is there and count and so many. The internal hardware organization of a digital computer is best defined by specifying the set of registers it contains and their function, the sequence of micro operations performed on binary information stored in the registers, the control that initiates the sequence of micro operations. Now register transfer language. In this topic we will try to understand what do we mean by the register transfer language and why we go for the register transfer language. A register transfer language is a system for expressing in symbolic form the micro operation sequence among the registers of a digital computer. It is a convenient tool for describing the internal organization of digital computer in concise and precise manner. It is possible to specify the sequence of micro operations in a computer by explaining every operation in words, but the procedure usually involves a lengthy descriptive explanation. It is more convenient to adopt a suitable symbology to describe the sequence of transfer between registers and various arithmetic and logic micro operations associated with the transfer. The use of symbol instead of explanations provides an organized and concise manner for listening the micro operation sequence in registers and control function that initiates them. Now register transfer. Computer registers are designated by capital letters, sometimes followed by numericals to denote the function of registers. For example, the register that holds an address for the memory unit is usually called a memory address register, and it is designated by the name MAR. Designations for other registers are such as we have program counter, PCIR instruction register. The following diagram shows the representation of registers in block diagram form. Such as we had four different registers. Register 1.2a, register R, is designated by its name register R. Similarly, we have shown individual bits in a register. It is an 8-bit register and it can store 8 bits starting from 0 to 7. Similarly, we can show numbering of bits. This is a 16-bit register. It can store data 0 to 15. That means it can store 16 bits including 0. Third is a register which is divided into two parts, such as program counter. It can be divided into two parts. One is PCL. Program counter L stands for lower order bits 0 to 7. Suppose we have 0 to 15. Number of bits is 0, 1, 2, 3, 4, 5, 6 up to 15. We can store 0 to 7. That is 8 bits in PCL. And PCH, program counter H, stands for higher order bits 8 to 15. Other 8 bits in higher order register. That means in general it's a 16-bit register divided into two parts. One part of it contains 8 bits and another part contains also 8 bits. But first 8 bits 0 to 7 will be called as lower order bits and 8 to 15 will be called as higher order bits. Normally we want the transfer to occur only under a predetermined control condition. This can be shown by means of an if-then statement. For example, if we have P equals to 1, then R1 R2. This arrow is called replacement arrow. It means that whatever is present in R1 will be transferred to R2 provided if P is equal to 1, where P is control signal and this control signal is generated in the control section. Now control function. A control function is nothing but it's a Boolean variable that is equal to 1 or 0. The control function is included in the statement as follows: P semicolon R1 replacement R2. That means until and unless P is not equal to 1, nothing will be transferred from R1 to R2, and this control condition is terminated by colon. This was all about the introduction about the register transfer and micro operations. In the next lecture we will go through the buses and memory.